Here's a quick summary of everything you need to know to understand particle physics. So we have matter in the universe, and matter in the universe can be split into two categories. So those two categories are called hadrons and they're called leptons. So leptons are things that you've all heard about before, because you've all heard about electrons way back when you're in year 7 and year 8. So an example of a lepton is an electron. Okay, so what leptons are is they can't be broken down into anything smaller. So electrons are the real particle, then their antiparticle is called positrons. So you have electrons and you have positrons. So an electron we write as E minus, and a positron we write as E positive. The antimatter has the exact same mass, but the opposite charge. Another example of an lepton is called a neutrino. So a neutrino has got 0 mass and 0 charge, and they're actually traveling for you all the time, but you can't feel their effects because they don't have any mass and they don't have any charge. And then the antiparticle of the neutrino is just a symbol with a line on top showing you that it's the antineutrino. Okay. Hadrons are then split into two further categories, and those two further categories are called mesons and baryons. Okay. So baryons and mesons can be broken down to something smaller called quarks. Okay, so baryons are always made of 3 quarks. They're either always going to be 3 real quarks, or they're always going to be 3 antiquarks. And then mesons are always made of 2 quarks, a real quark and an antiquark. Okay, so the 3 main types of quarks that you need to know about are called up, down, and strange. So an up quark has got a charge of plus 2/3. A down quark has got a charge of minus 1/3. And a strange quark has got a charge of minus 1/3. And you're given these numbers, but because you do it so many times, you eventually learn them. So then the antiparticle, so an anti-up quark, has got the same mass but opposite charge, so negative 2/3. An anti-down particle has the same mass but opposite charge, so plus 1/3. And an anti-strange particle has the same mass but opposite charge, so again, plus 1/3. So an example of a baryon, again, you've probably seen from as young as year 7, is a proton. Okay, so I want to figure out what's inside a proton. The first thing I know is it's a baryon, so it has to be made of 3 real quarks. Okay, so a proton is a real particle. It's got a charge of plus 1, and it has to be made of 3 real quarks. So I have to figure out what 3 quarks I'm going to put in a proton to make up a charge of plus 1. So to get plus 1, we can have an up quark, which is plus 2/3. I can put another up quark, which is plus 2/3, but now I'm too high, so I need to add a down quark, which is minus 1/3. So I know the 3 quarks inside a proton as UUD, 3 real quarks. Okay. A meson, an example you probably hear about, is called a pion. So a pion with a positive charge, and you figure out what quarks are inside it. So because it's got a positive charge, I know I have to have 2 quarks, a real one and an anti-one, to make up a charge of plus 1. So what I could do is, again, I could put my up quark in there, my real quark with a charge of plus 2/3. The only way to get a plus 1 charge is I need an anti-quark to make plus 1, so it has to be my anti-down. So it's going to be my anti-down quark to make plus 1/3. So overall, my charge is plus 1.